Modern tech enterprises have largely mastered the software architecture side of the equation. By breaking massive code bases into modular, decoupled microservices, engineering teams gain the ability to build, test, and deploy code independently. Yet the organizational structures responsible for writing that code remain trapped in a legacy standard. These enterprises continue to rely on rigid, functional matrix organizations and top-down hierarchies. This creates a structural contradiction. On the left, a clean, modular software architecture built for rapid delivery. On the right, a chaotic, tangled organizational chart built for bureaucratic oversight. When decoupled code routes through these highly coupled structures, operational friction takes over. The primary symptom of this friction is an execution imbalance. Delivery mechanisms become efficient at churning out code, but the organization's ability to observe user reality and validate strategy remains severely constrained. Shipping code at high velocity offers no advantage if the enterprise's structural design prevents the creation of actual value. In this state, the enterprise acts as an unthinking robot. It executes tasks with precision, but lacks any strategic awareness of what those tasks accomplish. By prioritizing output metrics like story points and release dates, the organization loses the ability to see if the product is actually meeting a customer need. The product operating model addresses this by shifting the focus from tracking internal output to measuring external business outcomes. Transforming the organization requires three specific vectors: optimizing human cognitive load, defining clean ownership boundaries, and aligning incentives with value. Escaping the build trap is a matter of human organizational engineering. Human working memory is the biological bottleneck that limits every software engineering organization. John Sweller's cognitive load theory posits that every team has a finite volume of mental effort available in their working memory, what we can call their perimeter of responsibility. Visualize team capacity as a dashboard gauge. First is intrinsic load, the basic mental effort to write code. Next is germane load, the cognitive bandwidth to solve complex problems and innovate. The rest is extraneous load, energy wasted on bureaucracy, complex dependencies, and poorly integrated tools. When extraneous load exceeds a team's capacity, software quality drops and deployment cycles stall, regardless of individual engineering talent. The Ringelmann effect shows that individual productivity decreases as group size grows. This happens because communication paths inside a large team multiply exponentially, which in turn spikes the extraneous cognitive load required just to keep everyone aligned. Amazon manages this through the two-pizza rule, capping team sizes at roughly 10 people to strictly limit these communication pathways. When a service grows too large for one team, the organization uses mitosis. The team splits into two independent units rather than expanding its headcount. Keeping teams small is the only proven method to preserve single-threaded focus and prevent the gridlock that comes with scale. These small teams operate under Conway's law, the observation that software architecture will inevitably reflect the communication structures of the organization that built it. If an organization is divided into isolated database, back-end, and front-end departments, the software morphs into a tightly coupled monolith reflecting those same divisions. Many practitioners attempt to use this to their advantage through the inverse Conway maneuver, deliberately redrawing the org chart to force a desired software architecture. This maneuver assumes a perfect reversal of Conway's observation, that if a lack of communication leads to separate modules, then forcing teams apart will automatically produce clean software interfaces. It is a logical jump that often confuses the social structure with the technical result. Simply drawing isolated boundaries on a chart does not ensure that clean, functional APIs will appear. To make these boundaries effective, you need a blueprint for how teams actually interact. This is the core of Skelton and Pies's team topologies framework. The model defines 4 team types. The first is the stream-aligned team. These units own an end-to-end customer journey and should comprise 90% of the organization. The second is the platform team. Their purpose is to build self-serve internal infrastructure, providing vending machine-style interfaces that reduce the cognitive load of the stream-aligned teams. The remaining topologies are enabling teams, who act as internal consultants to transfer skills, and complicated subsystem teams, who handle specialized technical niches like cryptographic engines. Implementing these 4 topologies turns Conway's law into a strategic tool. ensuring that the human communication structure supports the intended architecture. However, changing team names without changing decision rights results in Cargo Cult Agile, specifically the blind copying of the 2012 Spotify model. The Spotify framework relied on a matrix. A product manager pulled the team horizontally toward delivery, while a chapter lead pulled vertically toward engineering standards. This created an accountability vacuum. Without an engineering manager to resolve trade-offs, the squad fractured under competing interests. This illustrates the difference between traditional feature teams and empowered product teams. Feature teams wait for instructions. Empowered product teams own an outcome and have the authority to discover how to achieve it. Scaling this ownership requires a specific macro model. Airbnb unified its product and marketing functions to ensure every feature is built with a clear distribution strategy. Shopify uses a federated model. They maintain a solid central platform core while allowing a decentralized network of stream-aligned teams to innovate at the edge of the ecosystem. Regardless of the model, ownership requires granting a single team absolute authority over a specific business outcome. Even the best team topologies will fail if the organization's financial incentives reward output over outcomes. We map organizational effectiveness on two axes: autonomy and strategic alignment. High autonomy without alignment is chaos. High alignment without autonomy is the build trap. The product operating model occupies the top right, where teams have context to align and autonomy to act. Reaching this state requires a pivot in funding. Organizations must move away from rigid annual project budgets and toward durable team funding that is reviewed quarterly based on performance data. This solves the principal agent problem by funding persistent teams to solve customer problems rather than funding temporary projects to ship features. This model changes the role of leadership. Amazon employs the single-threaded leader, an executive who owns a single initiative with no competing priorities. Netflix relies on context, not control, where leadership's role is to provide strategic context rather than micromanaging technical decisions. Leadership shifts from being a bureaucratic approval gate to acting as a strategic guardrail. Modern leadership must act as a vanguard, smashing through bureaucratic roadblocks to clear a path for autonomous teams to move forward. Relabeling projects as products is corporate theater. True speed only exists when topology mirrors architecture, teams respect cognitive limits, and incentives target measurable outcomes.